Hi everyone, welcome to Space Lunar Academy. This is Mr. Colossa, and today we are taking a look at video number 3 of the Electric Circuits revision for exams. So this is the CAPS syllabus. In other words, if you're doing CAPS, in other words, if you're in South Africa, this is a perfect video for you. If you're in America or any other country, I believe this video will also work for you if you would like to understand how electric circuits work, because electricity is basically the same all over the world. It behaves the same way. Nothing is different. And also we're doing electric circuits. This is a revision. Basically we're doing question papers under the CAP syllabus, Department of Basic Education. You can get these question papers on the Department of Basic Education's website. Um, okay, so this is for grade 11 and grade 10, and grade 12 learners can also watch this video. However, note that this is a grade 10 question paper, so it's suitable for those who are doing grade 10 and grade 11. However, if you are doing grade 12, you can find another resource within the channel, or you can still watch this video to understand electric circuits. Otherwise, note that this video, this is a question paper from grade 10, and so it's suitable for grade 10 and grade 11. But for grade 12, the only part that's not involved is the EMF part. So that's why I'm saying this video is not for grade 12 really, unless you are new to circuits and you're in grade 12, or you would like to understand circuits, the basics, because this is the basics of electric circuits. Okay, so let's not waste time. Let's analyze the question and answer the questions. Analyze the circuit. Okay, in the circuit diagram below, the reading on the voltmeter V1 is 12 volts. So in other words, we have 12 volts on this voltmeter number 1, which is connected across this battery. Okay, I'm gonna try to move a bit faster in this video in terms of explanation, since in video number 1 and video number 2 I was moving a bit slower. I'm assuming that you've watched the previous videos, video number 1 and video number 2, so it's gonna be a bit faster in terms of explanation, but I won't be too fast. So the battery has 12 volts. In other words, it has an EMF of 12 volts. That's the amount of voltage that this battery will supply to the circuit. So it's 12 volts. Okay, and the reading on the ammeter A1 is 2 amps. So A1 reads 2 amps. So this is the total current. Why is it the total current? Because current comes from the positive terminal of the battery. Remember, we said the longer terminal or the longer line represents the positive terminal, and current tends to start on the positive terminal. What type of current? The conventional current. We use conventional current in electric circuits. So I'm saying conventional current starts to flow from the positive terminal of the battery to the negative terminal of the battery. So it will start here. So and as it passes through A1, it means it reads the total current of the circuit as it comes from the battery. So A1 is the total current. V1 is the voltage, total voltage from the cell. So this current will come to this point, and then at this point it will split according to the ratio of the resistance. In other words, there will be less current here flowing here in the 6 ohm resistor compared to the 3 ohm resistor. Remember, resistance is like friction. The more the friction, the less the current, because current is the rate of flow of charge. In other words, the rate is reduced by bigger resistors. So a bigger resistor will cause current to flow very slow. In other words, it will cause current to slow down. In other words, there will be less current flowing here compared to this one. We have to understand that. More current will flow through the 3 ohm resistor, and less current will flow through the 6 ohm resistor. Okay, and then this current will join again at this point and form the same amount of 2 amps of current that entered. Current that enters a loop or a joint or a branch, whatever, is the same amount of current that will leave the branch. So hope that works, because I already said that in the previous videos. I'm just reminding you so that when we answer the questions, we understand. Okay, now this current goes through. After passing this branch and joining at this point, it goes through 4 ohm resistor, but it remains 2 amps as it passes through the 4 ohm resistor. Why? Because current in series resistors, this is a series resistor, but these two resistors are in parallel. Okay, so when current passes through a series resistor, it remains the same. It doesn't change. It's not split or reduced or something. It remains the same. Okay, and then it returns back to the battery, and the cycle continues over and over and over again up until the voltage is finished. There's no more power or energy to push the charges, which is there's no more voltage. Okay, so let's answer the questions. I hope it makes sense. This is voltmeter number 2, of course, meaning we are trying to find how much voltage is used by the 4 ohm resistor if we are connecting voltmeter number 2. Hope that makes sense. Okay, let's answer the first question. Calculate the total resistance of the circuit. Remember, we said from the previous videos, if you have two resistors that are in parallel, you can add them together. They will form one giant resistor. One could be small, it doesn't have to be giant. I'm saying one resistor. They will form one resistor, and this resistor will be in series to the 4 ohm resistor. So you will end up having a circuit that has one resistor, and then the other one resistor, which is the 4 ohm resistor, and that battery of yours. That's your circuit. See, that's the kind of circuit you will end up with. If you add those two resistors, you get one resistor that is in series with that one, with the 4 ohm resistor. Hope it makes sense. Okay, let's do the calculations. We are required to find the total resistance of the circuit. So we know that RT, the total resistance of the circuit, depends on the resistance of the series resistor plus the resistance of the parallel resistors. Okay, so it means we first find the resistance of the parallel resistors, which is what is the resistance of the two resistors, because the resistance of this one is 4 ohms. But what is the total resistance of the two when they are added together? Since they are parallel, we use a formula for parallel resistors. So we said it's 1 over Rp, which is equal to 1 over R1 plus 1 over R2, since we have 2. So we're going to end at 2. If there were 3, we would say 1 over R3. But they are just two resistors that are parallel. So we add only 2. So that's 1 over Rp, which is equal to 1 over 6 for this one, and plus 1 over 3 for this one. Okay, hope that makes sense. So we end up getting a resistance of 1 over Rp is equal to let's punch that on our calculator. So 1 over 6 plus 1 over 3. You can punch that on your calculator. That's 1 over 2. You get 1 over 2. That's half. So if we cross multiply and try to solve for Rp, this is 1 over Rp. This is not Rp. We want Rp. So how do you find Rp? We cross multiply. This 1 multiplies the 2. Rp multiplies the 1. So therefore Rp will end up being equal to 2 ohms. You can do that maths. You end up with 2 ohms now. Why do we use the unit ohms? Because it's resistance. When you're calculating resistance, it becomes 2 ohms. So the RT, total resistance. So we're not looking for Rp, we're looking for RT. RT becomes RS plus Rp. Remember above we said if we want to find the total resistance of the circuit, we need to add the resistance of the series resistor and the one for parallel. So that gives us RS is 4 ohms. Where is 4 ohms? Here is the 4 ohms. Let's not forget. So where is the RP? RP, we just calculated RP. That's 2 ohms plus 2 ohms. So the total resistance of the circuit becomes 6 ohms. Oh, it makes sense. Ohm is like a symbol like this. Is ohm is omega. But because I'm trying to write like fast, so my ohm looks like this. The ohm symbol, the omega symbol. Let me try to draw it the right way. Cool. Okay. That's 6 ohms, the total resistance of the circuit. What does that tell you? What does that tell you? It tells you that, look at this, go to the formula for RP. RP is, we got RP to be 2 ohms. You see, adding two big resistors, look at this, 6 ohm and 3 ohm. 3 ohms. They are big resistors, but we got a total of them. If we add them, we got 2. So it means resistors in parallel reduce the total resistance. They become small. When you add them, you get a smaller total resistance. Okay, but the resistors in series result in what? Into a bigger resistance. Keep that in mind. It will help you because there may be questions. You may need it in the future. Okay, so we're required to find the reading on V2. What's V2? V2 is the voltmeter reading of 4 ohm resistor. In other words, what will be the voltage used by the 4 ohm resistor? Okay, we know Ohm's law says, okay, what is this number? This is 11.1.2. 11.1.2. Remember, 11.1.1 is the one we just calculated above, is this one. But it started from parallel, and it started here, 11.1.1. So 11.1.2, we're looking for V2, the reading in V2. Remember, Ohm's law says that if we want to find the voltage, we have to multiply the current with its resistance, by its resistance, I mean. So I is the current of that particular resistor, the current that passes through the resistor that we're dealing with. What is the current that passes through this 4 ohm resistor? It's 2. Remember, we said that the current joins here and becomes 2 again. So in the place of I, we put 2. In the place of R, we put 4. So that's 8 volts, or voltage is measured in volts. I'm assuming you already know that because I said that before. 11.1.3. Okay, remember we said we're going to move a little bit faster, but not too fast. I'm going to move fast such that you at least understand this. Watch video number 1 and video number 2 of electric circuits revision. This is video number 3. Remember, I said that this is video number 3. So in other words, there are already 2 videos on revision of electric circuits that you haven't watched if you haven't, but I already did them. Okay, let's find out the reading in A2. We are required to find the reading on A2. A2 is an ammeter. An ammeter reads current. So in other words, what is the current that passes through the 6 ohm resistor? The current that passes through the 6 ohm resistor, if we want to find it, if we want to find I, we need to know what's the V and what is R. What is V for these two, or for this 6 ohm resistor? Remember, the V for the 6 ohm resistor is the same as the V for 3 ohm resistor. Why? Because parallel resistors have equal voltage. Voltage for parallel resistors is the same. Keep that in mind. Voltage for parallel resistors is the same, meaning the voltage for this part 6 ohm is the same as voltage for 3 ohm resistors. So if we know that this one used 8 volts, From the 12 volts of a total voltage, it means that we will subtract the 8 that is used by the 4 ohm resistor, and we are left with 4 volts. This 4 volts is used by these two. It means if 6 ohms, if the 6 ohm resistor uses 4 volts, it means also this one will use the same voltage, 4 volts. Okay, keep that in mind. So we know voltage that flows in here, and we know R, we know V, we know R. It means we can find I, in other words, the reading in A2. Wow, that's simple. Okay, if you don't understand what I'm saying, watch the video again, pause it or move it backwards. I'm like, whoa, okay, what are you saying? And then you just move the back, play it back, watch it again. It will make sense. I'm saying that we know the current. What is the current that passes through this resistor? Now it's what we are looking for. We are looking for the current, meaning the reading in A2. So we know R. R is this resistance, which is 6 ohms. What is V? V is 12 minus 8, because all of this voltage will be used by all of these 3 resistors. So if this resistor already uses 8 volts, which is we already calculated before, so it means these two will use 4 volts, and resistors in parallel share the same amount of voltage. They have the same amount of voltage. If this is 4 volts used by this one also uses 4 volts. Keep that in mind. So that means the remaining 4 volts will be for both of these resistors, these parallel resistors. So yeah, we know V to be 4 volts, we know R to be 6 volts, we can find I2 or A2. Okay, let's do the maths. So reading in A2 or I2, I'm going to call it I2 because current symbol for current is I. I is V over R. V is 4 over R, which is 6. That gives us, if we punch that in our calculator, we will get a value of 0.67 amps. In other words, the current that flows through this resistor is 0.67 amps. So if out of the total of 2 amps, 0.67 flows through this one, it means the current that flows through this one will be 2 amps minus this one in order for us to get the current, meaning A3. So it's easy to find A3. If we are ever required to calculate A3, the reading in A3, then it shouldn't be hard. We just subtract 0.67 from 2 amps, which is the total. Okay, it should be fun. So we're saying that we're done with 11.1.3. Let's get to 11.1.4. 11.1.4. I hope I'm not moving too fast for you. Maybe if I am moving too fast, technology has made it so easy. You can slow down. You can get me to speak in slow motion, maybe if you feel like, this guy is speaking too fast. English is not even my mother tongue. I'm not a native. But hey, I'm speaking it. I try. We're not there. That's not the topic of the day. So let's. Oh, I was saying you can try to slow down, like reduce the speed. There are settings. I'm sure on YouTube you can do that. There are settings to slow down a video. But that's not the topic of the day. So let's calculate amount of charge that flows through ammeter A1 in 120 seconds. So let's go back to ammeter number 1, which is the total current. We want to find the amount of charge Q that passes through this. Okay, remember when you are given current and you know the amount, the time, you can find the charge. The time is 120 seconds. They want to find how many charges that pass through ammeter number 1 in 120 seconds. So we know I is equal to Q over delta T. So it means Q is equal to I times delta T. Those are the formulas for in electric circuits that we use for to calculate charge or change in time or current. So let's do that. Okay, let's go back. Let's scroll down and do the calculations. Q would be equal to I, meaning the current that passes through the A1, or the current that is read by A1 multiplied by the change in time. I is 2 amps multiplied by 120 seconds. So that is 240 charges measured in coulombs. Okay, I think I've exaggerated the coulomb, the C for coulombs, 240 coulombs. Great, that's cool. I hope it makes sense. This is just a formula. It's a well-known formula. I'm assuming you already know this formula. If you don't, just know it is one of the formulas that you will need if you want to calculate charge or current when given charge and time, or time when you given charge and current. Okay, time is in seconds, current is in amps, charge is in coulombs. Keep that in mind. Now let's do 11.2. We are almost done. You see, 17 marks. Whoa, that's a lot of marks. You can't lose this marks. You cannot just skip such a question. You see, this is just, we're just flowing. We're just flowing. Nothing is hard at all here. Okay, well, 11.2. 11.2. What are they saying? How will the reading on ammeter number 1, meaning how will the total current, remember A1 is the total current, how will the total current, that's what it's trying to say, how will the total current be affected if the 6 ohm resistor is removed from the circuit? Let's go back. Suppose we remove this 6 ohm resistor. We no longer have the 6 ohm resistor, so it means we no longer have all this branch now. We have two resistors now, 3 ohms and 4 ohm resistor. We no longer have the 6 ohm resistor. So it means this becomes a series circuit now. It's a series circuit. Ask yourself, what happens? Wait, RT just goes up. Why? Because resistors in series increase total resistance. Without RC, the 6 ohm resistor now, it means this is a series circuit. It was a parallel circuit and all in mixed. It was a mix, like a mixture of parallel and series circuit of series resistors. So now we've removed the 6 ohm resistor. It means this is a series circuit. RT will go up, meaning the total resistance of the circuit goes up. If the total resistance of the circuit goes up, let's say I is V over R. If this body or boy, whatever it is, resistance goes up, then it means current should go down. You see? But we haven't read the question completely. How will, oh it is, we did. They were asking what will happen to the total current if we remove this one. When we remove this one, the total resistance goes up, and then total current, it means it will go down. It will decrease. Total current will decrease. Let's read the question again. How will the reading on A1, it means how will the total current be affected if we remove this 6 ohm resistor from the circuit? Will the total current increase? Will the total current decrease or remain the same? Remember, I just said it will decrease. Total current will drop. Why? Because total resistance just increased, and according to Ohm's law, these two are inversely proportional. So we say it will decrease. So I'm sure there will be a question that requires us to explain. Explain your answer in question 11.2 without any calculations. We will need to explain why do we say it will decrease. That's 11.3. Let me check if my numbering is correct. Yes, it's 11.3. Numbering is correct. Okay. The reason why we said the current will decrease. Look at this. When 6 ohm resistor Tell the story, make the examiner understand, make anyone who is reading your question, your answer sheet, understand, make them understand when they read your paper what you wrote. We make them understand why you say it will decrease, why you say the total current will decrease. So when 6 ohm resistor is removed, RT increases, meaning the total current, the total resistance increases. Since the circuit becomes a series circuit. You know, a series circuit is a circuit whereby resistors are in series. Okay, an increase in RTN, increase. Remember, I'm just thinking as I'm writing this. An increase in RT results, results in a decrease in IT, meaning I total, meaning the total current. So when the total resistance increases, when the total resistance, when the total resistance increases, current will do what? Will decrease. An increase in RT, meaning the total resistance, results in a decrease in total current. Why? Who said that? According to Ohm's law. That is according to Ohm's law. According to Ohm's law. You can't just say something will decrease and then not explain why. There's gotta be some law that explains that. So we know that I and the resistance are inversely proportional according to Ohm's law. When this one goes up, this one likes to go down. Okay, hope it makes sense. I is inversely proportional to resistance. Okay, that should make sense. Wow, that is all about for this question. That is all for this video. I mean, that is all for this video. Hope it makes sense. Hope you enjoyed. Please note that sometimes my videos are long. So you would need, after 15 minutes, you would need to take a break, pause the video, take a break, and then do something. Maybe go drink some water, go take a mini jog, I don't know, and try to digest what I was saying, and then come back, keep on watching the video. That's how you revise question papers. That's how you prepare for exams. You don't try to cram everything at once. Nah, you're gonna get bored. It will confuse you. Take breaks, take minor breaks in between. Okay, this is all for this video, guys. I hope you enjoyed. If you did enjoy, leave a like, click the like button, subscribe to the channel, leave a comment. If you have some compliment or you have a complaint, or you have you have an advice for me, you feel free to leave some on the comments, on the comment section. I would really appreciate that. Thank you. See you in the next video.